Hello, everyone. A big thank you for joining this session, Architecting 5G Apps for Ultra-Low Latency on AWS Wavelength. I'm Saravanan Shanmugam, Senior Solutions Architect for AWS Wavelength. We announced AWS Wavelength at reInvent 2019 in partnership with telco carriers Verizon in the US and Vodafone, SK Telecom, and KDDI across the globe. We continued executing on this announcement and went GA with Verizon, bringing two wavelength zones online in Boston and San Francisco on August 6th, 2020. Till date, we have a total of 7 AWS wavelength zones in Boston, New York City, Washington, D.C., Atlanta, Miami, Dallas, and San Francisco. Our customers have started using the wavelength zones for deploying edge applications and combine that with the power of 5G to unlock its benefits. Let's get started. Let's look at the agenda for the session. We will do a quick overview of AWS Wavelength, why we built it, where does it fit, and what customer challenges it solves. We will also look at the typical reference architecture for deploying applications in the wavelength zone and how we combine with the services in the region. We will finish with a deep dive into various use cases that our customers are currently testing in the AWS wavelength zones. When you look at this slide, let's take an example. When a customer wants to deploy an application in the AWS cloud, the first thing that they do is they pick up an AWS region or they select an AWS region, they create VPCs, they create subnets, and then they start to deploy their applications. In this case, I'm showing the two ends of the slides. One end you have the region, the other end you have a mobile network. Right? The reason why we picked the mobile network in this case is we're talking about AWS Wavelength, right? AWS Wavelength is a mobile edge computing close to the edge of the mobile network, right? So typically when you deploy an application and you serve the application to your end users, and when you want to connect the end users to the applications which is running in the region, the packet flows from the end users in the 5G network or the 4G network through the radio network, through the packet core, and through the carrier backbone, internet, Amazon backbone, and then finally it reaches the applications which is running in the region. If you look at this path has such a high latency with variable delay and jitter, and especially it's a best effort traffic, right? It's a best effort path. And the challenge with this is some of the applications with 5G is bringing to the table with ultra low latency and other aspect of 5G network. This particular architecture doesn't scale well for those type of applications. And more importantly, if you're following along 5G dramatically changes the landscape in which devices can generate or consume more data and more bandwidth, right? They're talking about 10 gigabits of throughput that every device can get in a 5G network. So the entire architecture is going to create a lot of data from a 5G network all the way to the region. So there's going to be tremendous pressure on the backhaul networks as well as the packet core and all the way back to the region. So how do we handle that scenario? And also, even without 5G, how we are trying to solve the problem in terms of reducing the latency between the applications which is running in the region and the client in a mobile network, right? AWS has been trying to solve this problem with so many different ways, right? So if you overlay the mobile network, the radio network, the backhaul, the packet core, and the data network, so that's the route that the packet takes, right? Before it gets onto the internet to reach the applications which is running in the region. But we're trying to solve this problem in many different ways, right? One of them is we try to bring individual services like CloudFront and Direct Connect and Global Accelerator and Lambda at the edge. These are individual services we bring close to the edge of the network, trying to reduce the latency of the applications so that we can improve the user experience a little bit, right? But AWS Wavelength is a completely different thought process. So let's look at what AWS is trying to do. Instead of bringing individual services to the edge of the network, with our partnership with carriers like Verizon, we are bringing AWS infrastructure and core compute services like EC2, EBS, container services like EKS and ECS into the carrier network and place it next to the packet core. This AWS infrastructure inside the wavelength zone, inside the carrier network is an AWS wavelength zone. We connect wavelength zone back to the parent region using service link through which the application in the wavelength zone can take advantage of other services in the region. By reducing the number of hops between the end user and application that is running in the region, we are reducing the application latency and improving the end user experience. Customers can now run ultra low latency applications on AWS infrastructure and services at the edge. We are introducing a new networking resource along with it called Carrier Gateway, which helps the customer's traffic, which originates from the wavelength zone, to be routed back to the packet core and to the carrier network, and also provides the NATing function for the traffic that originates from the subnet inside the wavelength zone back to the carrier network. Right? We have slides where we will talk about different packet flows in and out of the wavelength zone. So when you compare carrier gateway with an internet gateway, they both are pretty similar, right? An internet gateway in the region allows you to route traffic from your AZ subnets, from subnets in the availability zones to the public internet. But in the case of carrier gateway, it allows you to route the traffic from the wavelength zone back to the carrier networks. So now if you really overlay the mobile network across on where wavelength zone is, you can see wavelength zones are deep into the packet core, close to the packet core. In fact, we co-locate our wavelength zones where the packet core actually happens. So in the 5G network, if you know, there is something called a UPF function, a user plane function. So that's where the wavelength zones are. We place them as close as possible to the packet core, so we reduce the latency of AWS services, packets, and services accessing the applications which is running inside the AWS services. Okay, so let's move on to the different packet flows in and out of the wavelength zone. Right, as I said, this is a slide which kind of gives you a 10,000 foot level of the entire end-to-end wavelength zone architecture. Right, so we have wavelength zones inside the carrier data center, and then we connect them back to the parent region using service links, highly available, redundant, and scalable links which connects back from the wavelength zone. And then we also have this new network resource model called Carrier Gateway, which routes the traffic from the wavelength zone into the packet core. So as a developer, as you get started with wavelength zones, the first thing we tell developers is, look at wavelength zone as another AZ, right? Another availability zone. So as I mentioned, if a customer wants to start deploying an application, the first thing that our customers do is they create a subnet, and subnet is the abstraction of an availability zone, right? That's exactly what you're doing when you start to deploy your applications inside the wavelength zone. You create a subnet, and logically your VPC extends from the parent region, and then you deploy your instances in the wavelength zone inside that subnet. So as you do that, the default route table, the default VPC route table, seamlessly extends to the wavelength zone as well, right? When I say extends, any packet that originates from the wavelength zone is treated as a packet that is originating from any subnet in the region or any AZs in the region. So packets can be seamlessly routed back and forth between an AZ in the region as well as a wavelength zone in the carrier data center. So customers do not have to do anything in terms of routing their traffic from a wavelength zone back to the region. That simple it is. And the other traffic which is very important is the traffic that originates from the carrier side of the network, which is what most predominant traffic is going to be, where you're going to serve applications to the 5G users and the 5G networks and the 5G devices from the carrier side of the network. That's going to be the predominant amount of traffic that is going to come and come into your wavelength zone, right? So that's where the carrier gateway becomes very important. In this case, you have to create a new route table, a custom route table, and then attach that to the subnet inside the wavelength zone. And also create a default route, as you see in the slide, pointing that default route to the carrier gateway. So what that does is any traffic that originates or any traffic that hits the wavelength zone needs to be routed back to the carrier network is routed using that subnet table, which tells that any packet beyond 10.0.0/16 has to be routed through the carrier gateway. So that's how you connect to your applications, or you connect to your clients who are in the carrier networks. And using this particular route table, you can also route traffic from the wavelength zone to the internet, right? Our customers are looking for ways to say they want to download a Docker container, or they want to actually upgrade the operating system, or they want to connect to their data center outside the AWS cloud. So they can actually route through the carrier gateway, through the carrier's backbone, and they can reach any internet destinations. And carrier gateway would do that NATing function as well when you want to reach to external internet destinations. And finally, when customers start to understand how packet flows in and out of the wavelength zone, and they want to start architecting applications, the first question they ask is, I want to reach out to back to the region, and I also want to write some data into my S3 bucket in the region, right? By default, if you want to, you can actually go through the default route and go through the internet to reach the S3 destinations, or we also support gateway endpoint, right? A gateway endpoint support is for S3 and DynamoDB. So you can create gateway endpoint, which adds that S3 prefix route table entry into your subnet, and then you can seamlessly reach S3 from a wavelength zone using the S3 gateway endpoint. So as you are used to defining gateway endpoints in your AZs in the region, that's exactly how it works when you define an S3 gateway endpoint inside the wavelength zone, right? As you start getting used to deploying and creating VPCs, creating subnets in a wavelength zone, and start to deploy applications and connect that seamlessly back to the other parts of your stack, which is running in the region, you absolutely see that wavelength zone from a developer standpoint of view, it's another AZ, right? Even though it is running inside a carrier data center, AWS infrastructure inside the carrier data center, but it's very, very, very transparent to a developer that this is basically another AZ, right? That's how wavelength zones are presented to our customers as well as developers. So as we move on, I just wanted to talk about how customers are looking at wavelength zones and how they are architecting applications inside the wavelength zones, right? This is the most important part of my role as a solutions architect for wavelength, is working with customers day in, day out, and helping them understand the value proposition of wavelength, and also help them architect their applications inside the wavelength zones, right? So if you look at this, if you look at this slide, or if you look at this particular architecture, if not for wavelength zone, as I mentioned before, with 5G, we are talking about tens of gigabits of traffic being originated by one device, right? One device, upstream of 10 gigabits per second, downstream 10 gigabits per second, even though it's theoretical limit of what 5G specifies, but carriers like Verizon's and other carriers are getting there theoretically, and as well as proving that it is possible. In the last test that Verizon released, they actually showcased that they can actually get 4 gigabits download speed from a 5G device running in a 5G network. That's an amazing accomplishment, and we're slowly going to get devices and chipsets and radio networks which are going to continuously improve and get to the point of downloading and uploading 10 gigabits per second of data, right? If you think about it, more devices, millions of devices, in fact, billions of 5G devices are going to get into the market and generating lots of data using the 5G network. So if you don't have much of edge processing, all the data that is generated on the radio network has to be backhauled all the way to the region. So as a customer, as an ISV or an enterprise who wants to support 5G applications for their customers, now you're looking at the challenge of transporting terabits of data, hundreds and hundreds of gigabits and terabits of data, all the way from the 5G network to the region, right? Which is very difficult for the carrier, as well as for all the intermediate routing functions that is in the internet to route this traffic all the way to the region. It's even a burden on Amazon backbone when you look at tens and tens of more times of data that is going to hit the backbone. So everybody has to invest in their backbone to handle this amount of data that is going to come through the backbones, through the internet, and through the Amazon backbone into the region. So how do we solve this problem? And that's where edge computing becomes very important, right? So if you look at this picture, or if you look at this particular component of the slide, you can see that these hundreds of gigabits of data which is being generated on close to the radio network, we can handle that explosion of data as close as possible to the edge, doing edge processing, doing computation on the data, doing inference on the data, doing processing, and doing lots of cool things about different use cases. You tend to reduce the amount of data that need to be sent back to the region, right? That's one of the important aspects of edge computing. We talk about ultra low latency applications, we talk about high bandwidth applications. All these applications can be served as close to the edge of the network. You're tremendously reducing the capacity required in the backhaul. That is also another important aspect of edge computing, especially wavelength, which provides the capacity and AWS infrastructure close to the edge of the network. It dramatically changes the landscape of networking on how do you do 5G applications, right? You don't have to necessarily send all the traffic back to the region. And if you expand on that, as more and more wavelength zones come to fruition and come on live with carriers, you're basically seeing a dramatic reduction of traffic that needs to be routed back to the backbone and can be handled very distributedly across the carrier backbones in different parts of the cities, right? As I mentioned, we already have 7 wavelength zones online, 6 of them along the East Coast, and one of them in Dallas and one of them in San Francisco. Without those wavelength zones and all the data traffic that is going to be created by the 5G network in these metropolitan cities, Verizon has to route this traffic all the way back to the region. But now with wavelength zones close to the edge, customers are now can leverage the benefit of AWS infrastructure and services close to the edge and deploy applications at the edge, right? It's a tremendously different way of thinking of how do you deploy applications at the edge, and that's what AWS Wavelength brings to the table. Okay, so let's look at different use cases, right? That I mentioned. If you look at different use cases, right? When I talk to customers, right, on different use cases, let's look at different types of use cases, different vertical of use cases, different industries and different segments which is positively impacted because of 5G. And there is a lot of research and innovation going around this field on what type of application is suited for 5G, right? What are the things that I need to be aware of deploying an application at the edge? And how do I combine that with the power of the services running in the region? That is most important, right? As I mentioned, the wavelength zones are an extension of AWS Cloud to the edge of the network, right? And I also mentioned AWS wavelength zones are typical to an AZ, but the number of services that is available in the region and compared to the number of services available in the wavelength zone is dramatically different, right? In fact, we support the core foundational building blocks of AWS services like EC2, EKS, EBS, and ECS, right? Those are the 4 services natively supported inside the wavelength zone. But you have 180 plus services which is there inside the region, right? So how do I manage the services in the region, and how do I actually leverage the 180 plus services in the region and these 4 services, core services available in the wavelength zone? And that's where looking deep into the use cases and understanding and helping customers to disaggregate their applications between the services in the region and the services in the wavelength zone becomes very important. So if you look at inference at the edge, this is a massive use case as far as edge computing is concerned. There's not one area of implications that inference at the edge is going to affect, right? If you look at any type of use cases which needs to process data at the edge as fast as possible, run some machine learning model on top of that data, either it's a time series data or it's a streaming video data or it's a still picture or it's a data from IoT devices. At the end of the day, it's some data is being streamed as fast as possible in a 5G network with a very high bandwidth, and somebody has to manage this data coming into the wavelength zone and run some machine learning model on top of it and do some inferences and send back the inference results so that something can be done where the data originated from, right? If you take autonomous driving use cases, if you take safety use cases, if you take robotics use cases, lots of these use cases are streaming data, streaming video, streaming pictures, streaming some measurement data, and these data have to be processed and sent back as quickly as possible so that the source can do something different about based on the data it has been analyzed, right? So if you look at this use case, customers use G4 instances, use R5 instances to run their model to do inference at the edge. They also have caches where they can quickly query a database, in-memory database, so that they can quickly refer to the inferences during the history or do some analytics and then send back the references. But as they collect these more data sets, they have to send it back to the region to improve their model that they have built in the region, right? So the beauty is you still are taking the benefit of all these services in the edge, all the services in the region to continuously improve your model using SageMaker, using S3, using Jupyter notebooks, and lots of model training you do in the region, and push back the artifacts when it is ready, and you do the inference at the edge in a very low latency fashion. That's what that disaggregated model brings to the table. Leveraging the services in the region and using the core foundational services for running your inference at the edge. As I move along, there are other use cases, right? Analytics at the edge. This is very similar to what I talked about as far as the inference at the edge is concerned. In this case, the data stream is different, right? In the case of inference at the edge for your streaming video, in the case of data analytics at the edge, your data source differs, right? But pretty much the same, right? As far as edge analysis is concerned, you have a GPU instance or you have a CPU instance, you want to run the model and you do some analytics at the edge for the time stream data or IoT data sets, and as fast as possible, you're sending the inference back to the data source. All right. Another one is automotive use cases. Massive opportunities for ISVs and OEMs and carriers, and anybody who's in that industry will tell you that automotive use cases like CV2X and ADAS use cases are very important for the future, right? There is so much of processing has to happen at the edge in real time and very ultra low latency, less than 15 milliseconds or so. It has to happen as quickly as possible. Carriers as well as automotive manufacturers are looking at how do I leverage the compute inside the cars and inside the automotives along with the compute which is available in the edge. How can I combine the power of 5G along with the compute at the edge, and also how will I leverage the analytics stack which is available in the region, right? So you're combining the power of 5G, you're combining the power of analytics, running analytics at the edge inside the wavelength zone, along with an offline data analytics, and constantly building your model, constantly improving the insights of data that you're getting from your models, and improving that effectiveness of your entire workflow, right? That's exactly what you're doing as far as automotive use cases are concerned. We do have several use cases that I will talk about as we move along, but I wanted to continue. We have seen use cases where smart factory and robot use cases, like autonomous manufacturing, improving the quality of quality control by means of leveraging edge computing. There's lots and lots of use cases as far as smart factory and robots are concerned. And one final vertical that I really want to mention is media and entertainment. We have been talking with tens of different customers in the media and entertainment space about how to leverage 5G and how to remove the dependency of on-site hardware as much as possible, and to enhance their elasticity and scalability of doing production at the edge, right? Remote video production at the edge, streaming at the edge, caching at the edge. There's a lot of media and entertainment use cases that we have been talking with companies like Sony, which was publicly referenceable during our G announcement, and also some other customers who really wanted to take the benefit of 5G and think differently on how media and entertainment is done today and how they can dramatically change the landscape of the broadcast industry. Right? So these are some of the very high level vertical use cases, and how do you combine the power of services in the edge and the AWS services inside the region. Okay, and obviously you are you can leverage all the DevOps tools and management tools and application development tools, CloudWatch metrics and CloudTrail. All those things are still available, right? It doesn't mean that since there's only 4 services are available, you can't do CloudWatch. Absolutely not, right? So CloudWatch is a region level services which is still applicable for all the instances and all the applications which is running inside the wavelength zone. But the core services we provide, as I mentioned, is the compute, storage, and container services, which is what is most important for most of the edge use cases. And we certainly are working backwards from our customers to understand what additional services are relevant for edge. Right, we're not going to bring all these 180 plus services into the wavelength zone, which is certainly not required. We work very closely with all our customers who are very interested in the 5G space, who are constantly innovating and bringing in new use cases, and learn from them and see what additional services is important for accelerating the deployment of applications in the wavelength zones. Okay, let's quickly look at the different use cases. Virtual reality implementation is actually challenges the boundary of 5G and edge computing, right? If you looked at VR, AR use cases, it requires a very ultra low latency path, and most of the time it's always tethered devices, right? So you have a massive compute closer to where the VR games are being played, or VR scenarios are being played, and that's because the latency that is required between the user and the application and the compute is very, very, very small, like in the single digit milliseconds. And that's why there's always big compute close to where the VR applications are run. But with 5G and the promise of reducing the latency into single digits as we move into optimized 5G implementation with standalone and millimeter waves and all kinds of technologies, it's now a possibility that we can certainly think of eliminating the need for on-site computes and leveraging G4 instances, which is running in a wavelength zone, along with 5G. There is a possibility, and in fact, we have customers, proof of concept customers. We are testing out VR applications without the need for on-site compute, without the need for high-profile GPU instances close to the source of the data, and run them inside the wavelength zone. Fascinating use cases. When I started in this field, I thought VR is basically for gamers. I'm not a gamer, but when you start to look at different opportunities, there is a lot of enterprise VR applications, safety use cases, collaborative use cases, connected engineer use cases. Plenty of them are available for VR applications, right? Like the one that I wanted to mention is we are working with a very big industrial customer who really want to do innovative things as far as VR is concerned, like a connected engineer or a remote engineer collaborative use cases, where these engineers work in the oil fields and in the field, where they want to have some real-time interactive with the expert sitting somewhere not in the field, somewhere in the control center. How do they have this real-time interaction with the equipments and the device? And that's where VR could be a massive hit in terms of deployment, right? They don't have to carry the headset with that the massive compute in them. They can certainly have a lightweight headset, and they can stream the data using 5G and do the processing inside the wavelength zone using G4 instances. This is I can certainly count for VR use cases going to be a massive applications as far as 5G and wavelength is concerned. So moving on, machine learning at the edge, right? Industry 4.0 initiatives. Industries are looking at how to automate, how to become more nimble, and how to actually improve their workers' capabilities. Today, there's a lot of Industry 4.0 initiatives that has been rolled into motion. But if you look at it, most of them are using on-site compute, right? On-site compute with GPUs and CPUs, which runs the model, which uses the data that is being generated in the factory floor and does the modeling. And in fact, some of the data can actually go to the cloud for offline data analysis. But the most important thing is, how can we leverage 5G with wavelength, with edge computing? Can we actually do something about reducing the dependency of on-site hardware and move this hardware away from the industrial complexes and make them focus on what they have to focus on, right? Not to worry about maintaining that IT infrastructure, maintaining that hardware infrastructure, constantly updating and patching the hardware infrastructure inside the industrial complexes. Can they get that cloud model, the benefit of cloud model at the edge, and completely, I would say completely, but most of the use cases can leverage the 5G and the wavelength zone computes by means of reducing that latency. And this is where we worked. This was one of the announcements we made along with TCS, a global SI partner that we worked with, where they showcased that you can actually take an application, a smart industry application, use machine learning at the edge using wavelength, and combine that with the high bandwidth that 5G provides and low latency that 5G provides. You can basically eliminate the need for on-site compute. A massive evolution of opportunities for Industry 4.0 initiatives, which we believe will strongly accelerate adoption of 5G and industries moving towards edge computing infrastructure and applications. The retail industries, right? The retail industry is another important aspect where we are working with our in-house customer as well as other customers where they want to dramatically change the user experience by means of cashierless experience or walkout experience and things like that, right? So Amazon Go is an example. There are other retail wants to use that innovative way of making shopping and grocery and all these things very innovative for the end users. And again, back to the same thing, right? I sound like a broken record, but the key aspect here is how can I leverage 5G and edge computing, right? And how do I leverage and how do I expand that by means of using AWS Cloud? Here, you're moving all the computes from your retail stores, doing data analytics and moving that to the wavelength zones, and then basically doing analysis, real-time analysis inside the wavelength zones. Moving on, another one, data analytics. Shot Tracker is an example which was referenced. This is a cool sports tracking company where they do real-time analytics of sports games and track players and track the balls and do real-time statistic analysis. They currently do a lot of analytics inside the stadiums with an on-site compute. And now, when we provided them the opportunity to do a POC with us, they were like happy enough to test out. And there's a cool video if you have to go and look at the product page where you can see how they tested with on-site compute and without on-site compute, and the analytics is running in the wavelength zone. You're massively almost the same user experience when the compute is run inside the wavelength zone, right? So moving along, healthcare industry is another example. Avisha is another partner that we worked with, which was publicly referenceable, where they moved their on-site analysis of images, real-time images, and helping the doctors, and move that from the on-site and move them into the wavelength zone for deploying their deep data analytics applications and deep machine learning analysis inside the wavelength zone with the power of 5G. ADAS and CV2X use cases that I mentioned, autonomous driving, safety use cases, cellular vehicle to everything use cases, is a massive industry as far as 5G and edge computing is concerned. We are working with Savari, the likes of Savari and LG, which was publicly referenceable. They are starting off showcasing their location-based services, safety use cases, pedestrian safety, driving safety by means of leveraging the onboard compute and along with the edge compute with wavelength and 5G. They are changing the way that the end-to-end model is being done as far as CV2X use cases are concerned. Last but not least, the media and entertainment use cases. Working with companies like Sony, we are trying to change the landscape in which the broadcast industry is going to change, right? Instead of doing all the local transcoding and switching and all the big equipments which sits outside the stadium, so what Sony is trying to do is, can I leverage 5G and move some of these heavy computes away from the stadium and do my edge processing and mixing and switching, all these media and entertainment processing inside the wavelength zone so that I can reduce the investment of bringing in tens of different trucks inside the stadiums and can leverage that cloud model and run my video applications, transcoding applications inside the wavelength zone. It's a massive one. We did a tech talk on this one as well a couple of days back. So keep a watch out for the media and entertainment use cases as well as other applications. Couple more I just wanted to touch base real quick is there's a different way of transporting video, right? Traditionally, broadcast has been done using satellites, but now some customers are looking at how do I leverage 5G to broadcast my videos and to distribute my videos using 5G and wavelength rather than using satellites. This is another one. Look out for some customer references coming up very quickly in this space. We are working with Zixi and other ISVs who make a big play in this industry, and also with our own elemental services. We are trying to build reference architectures for media and entertainment customers, very specifically around video transmissions using 5G network. And last but not least, I just want to touch upon caching from the edge. Most customers ask, why do you even worry about caching if there is a massive footprint of CloudFront and other caching providers, right? What we are trying to say with caching from wavelength zone is there is a need for 4K and 8K video streaming, which is coming up in the industry. So all we're trying to say is build a hybrid architecture where you can send low bitrate streaming through the existing traditional CDN, and also looking at how do you do high bitrate streaming, 4K and 8K resolution video quality through the wavelength zone, right? So we have customers looking at a hybrid architecture, mixing wavelength zone caching zones as well as CloudFront caching. This is a tremendous space as well that we are watching and working with our ISV partners in the caching from the edge space. Finally, I just wanted to thank you all for joining the session. So if you want to get started with Wavelength, please visit these links. And if you want to access Wavelength Zones, please sign up. I provided the links there. And with that, thank you so much for joining the session. Hopefully this was useful to understand what Wavelength is all about and the benefits of edge computing along with 5G, and how to leverage and architect applications between services in the region and the services that we offer in the Wavelength Zones. Thanks again. Have a nice day.